In today's lesson, we'll be looking at substitution in logarithms, and that is the first part. And if you haven't subscribed to this channel, kindly subscribe so that when a new video is being uploaded, you'll also be the first person to be notified. Now let's get started. So we have our first example here. In example 1, it says that suppose log 2 base 10 is equal to 0.301 and log 3 base 10 is equal to 0.477. Use these values to find the value of log 6 base 10. So in questions like this, our task is to ensure that we express the given logarithm, that is log 6 base 10, in such a way that we get log 2 base 10 or log 3 base 10 or both, so that we substitute their respective values to get the solution to log 6 base 10. Now, let's write our question. So you have been given log 6 base 10, that is logarithm of 6. Now let's write it well. So you have been given the logarithm of 6 base 10. So now the question is, how do we express log 6 base 10 in order to get log 3 base 10 or log 2 base 10 or both, so that we can do substitution with their respective values? Now, in expressing log 6 base 10 or any logarithm of such, we should consider the fact that the given logarithm can be expressed as 1, product of 2 or more numbers, 2, can be expressed as quotient of 2 or more numbers, and 3 can be expressed as base and exponent of a given number. So when we take log 6, we know log 6 can be expressed as product of 2 numbers. So that implies that log 6 is the same thing as 3 times 2 base 10. And we all know that 3 times 2 gives us 6. So that is log 6 being expressed as product of 2 numbers. Now, we can see that this has been written as a single logarithm, so we can expand by using the laws of logarithms. And here we are going to have logarithm of 3 base 10 plus logarithm of 2 base 10. And this is how we expand using the laws of logarithms. Now, we can see that there is log 3 base 10 here and log 2 base 10. And these logarithms values has been given to us. So for log 2, it has its value as 0.301 and log 3 as 0.477. So we are just going to do quick. For log 3, we know its value to be 0.477. So we write here as 0.477. And for log 2, we know its value to be 0.301. So we write here as 0.301. And when we sum these two, we are going to have our answer as 0.778. So that is how we can find the value of log 6 base 10 with the help of log 3 base 10 and log 2 base 10 and their respective values. Now we said that log 6 base 10 should be a number that can be expressed as product of 2 numbers, and that's what we've done. Now let's try how we can use the quotient also to see how best we can use that and find the value of log 6 base 10. So it implies that using the quotient condition, then we are going to have here as log 6 base 10, which is the same thing as the logarithm of 60 out of 10. And that gives us the same thing as 6. We have our base 10 here. Now applying the laws of logarithms, then we are going to have here as logarithm of 6, that is logarithm of 60 base 10, minus logarithm of 10 base 10. Now we all know that the logarithm of 10 base 10 is the same thing as 1. So we are going to have 1 here. And we maintain the logarithm of 60 base 10. Now, from the values given to us, we are given logarithm of 2 base 10 and the value for logarithm of 3 base 10. We are not given the value of logarithm of 60 base 10. So since that value cannot be found in our simplification, we cannot continue with this. We can continue by further breaking the 16 down, and it's going to involve a complex number of solutions and procedures. So to be at the safest side, first try with the product. If it doesn't work, you go to the quotient and it follows to the base and exponents. So it means that for log 6 base 10, we can use the product condition, and that's going to help us get the solution to our question. Now let's try the next set of questions. So in example 2, it says that if log 36 base 5 is equal to 2.2265 and log 4 base 5 is equal to 0.8614. Evaluate log 9 base 5. Now we said that for questions like this, the given logarithm, that is logarithm of 9 base 5, should be a number that can be expressed as 1, product of two numbers, 2, quotient of two or more numbers, and 3, a base and exponent. Now looking at log 9, it can be expressed as product of two numbers, which means that our logarithm of 9 base 5 is the same thing as the logarithm of 3 times 3, and that gives us 9. That is correct. So in this case, we can use the laws of logarithm to expand. You are going to have logarithm of 3 base 5 plus the logarithm of 3 base 5. Now, per the logarithm and its values given to us, there is no logarithm such as log 3 base 5 in it. We are given just logarithm of 36 base 5 and then logarithm of 4 base 5. So since these values cannot be found, then we cannot use log 3 base 5. So it means this procedure is not going to work for us. Now the next one is logarithm of 9 being expressed as quotient of two or more numbers. Now applying that, then we are going to have our solution as. So at this point, we can see that 9 is a number that can be expressed as logarithm of 36 out of 4 base 5. And yes, 36 out of 4 gives us 9. So if that continues, then our solution becomes logarithm of 36 base 5 minus the logarithm of 4 base 5. So we expanded using the laws of logarithms. Now the value of log 36 base 5 is giving us 2.265. So write here as 2.2265 minus log 4 is also giving us 0.861. So having substituted their values, then 2.2265 minus 0.8614 gives us 1.651. And that is how we can find the value of log 9 base 5. Now the next one also said that we can express the given logarithm as a base and exponent. Yes, it also works. So we have here as log 9 to be the same thing as logarithm of 3 exponent 2 base 5. So at this point, we are going to have here as 3. Sorry, it's going to be 2 logarithm of. So that is writing the exponent 2 as a coefficient to the logarithm. That is 2 logarithm of 3 base 5. But from the values given to us, there is nothing like log 3 base 5 here. So since that does not work, then we cannot continue with our solution. So using this procedure is not going to work for log 9 base 5. So the only solution we can apply here is for us to use the logarithm of 36 divided by 4 in finding the solution to log 9. So this is the perfect solution for this question. Now let's try the next set of examples. Example 3 says that without using calculator or tables, find logarithm of 27 base 10 and logarithm of square root of 5 if logarithm of 3 base 10 is equal to 0.47712 and logarithm of 5 is equal to 0.6990. Now taking it one by one, then we are going to take the first one. So we have yes the logarithm of, that's the I part, the logarithm of 27 base 10. Now we ask ourselves, 27 can be expressed as product of two numbers, quotient of two numbers, and base and exponent. So the only thing that's going to work for us here, considering the values given to us here, then we are going to use the base and exponent. So that is the logarithm of 3 exponent 3 base 10. And we know 3 exponent 3 gives us 27. Now writing 3 exponent 3 as quotient to the logarithms, considering the exponent here, then we are going to have here as 3 logarithm of 3 base 10. So we use this by taking into consideration the laws of logarithms. Now we have the value of log 3 base 10. So we just write 3 here. We substitute the value of log 3 base 10. That is 0.477 0.712. And at the end, our final solution now becomes 1.43136. So that is when 3 multiplies 0.47712. So this becomes the solution to log 27 base 10. Now let's try the next one. That is the logarithm of square root of 5. So we have here as the II part saying that the logarithm of the square root of 5. Now remember that this logarithm, its base is not written, and we know that its base is in log 10. So it's going to have the base of 10 here. Now we can rewrite this as logarithm of 5 exponent half, knowing where that this exponent half is the same thing as the square root we have here. Now applying the laws of logarithms, you can write this half as a coefficient to the logarithm of 5 base 10, and this becomes half log 5 base 10. Now we know the value of log 5 here, base 10, to be 0.990. So we do quick substitution, and we have half multiplied by 0.6990. Now what is half of 0.6990? It's nothing but 0.3495. And this is the solution to this question. So it's just by using the products, the quotient, and then the exponent procedures, and at the end it's going to be so simple and so easy for you to solve. Now let's try the last set of examples for today's video. Now in example 4, we have given that logarithm of 6 base 10 is equal to 0.7782 and logarithm of 2 base 10 is equal to 0.3010. Find, without using tables or calculator, the value of log 80 base 10 and the value of log 600 base 10. So let's take it one after the other. So the first one, it says that we should find the value of logarithm of 80 base 10. Now we ask ourselves, how can we express logarithm of 80 base 10 so that we get logarithm of 6 base 10 and logarithm of 2 base 10, so that we do the quick substitution or any of these in log 80 base 10. Now we know that 80 can be expressed as product of two numbers by considering the logarithm of 8 times the logarithm of 10. We have our base 10 here. Now we can see that this has been written as a single logarithm. So expanding, then we are going to have the logarithm of 8 base 10 plus the logarithm of 10 base 10. Now we can see that 8 can also be expressed as a base and exponent by considering 2 exponent 3. So now we are going to have here as logarithm of 2 exponent 3 for 8. We have our base 10 here, plus now logarithm of a number to the same base gives us 1. So that is logarithm of 10 to the base 10 gives us 1 here. Now we continue, and we can see that for logarithm of 2 exponent 3 base 10, it can be written as 3 logarithm of 2 base 10 plus 1. So having known this, we have been able to see logarithm of 2 base 10 here. So by doing the quick substitution, then we know the value of logarithm of 2 base 10 as 0.3010. So we substitute, and we have here as 3 multiplied by 0.3010, and then not forgetting that there is plus 1 here. So at the end, when we multiply 3 by 0.3010 plus 1, we are going to have 1.9030, and that becomes the value of the logarithm of 80 base 10. Now, having known this, let's try the last example for today's video. Now let's take the second one. It says that we should find the logarithm of 600 base 10. So we ask ourselves, in what way must we simplify 600 base 10 so that we can see any of these, either log 10 base 10 or log 2 base 10, or the two of them in the simplification, so that we do the substitution necessarily. Now we can see that the same way we did for log 80 base 10, the same procedure we are going to apply to simplify log 600 base 10, which implies that we can write this one as logarithm of 6 times 100. And that absolutely gives us 600. Now we can see that this has been written as a single logarithm. So using the laws of logarithm to expand, we are going to have here as logarithm of 6 base 10 plus the logarithm of 100 base 10. Now we can see that there is logarithm of 6 base 10 here, that is 0.7782, and now simplification we can see that there is logarithm of 6, so that one is catered for. So what is left is for us to rewrite our logarithm of 100 base 10 in a simplified form. We know 100 can be written as the logarithm of 10 exponent 2. Then 10 exponent 2 gives us 100, and then we have our base 10 here. Now to continue, then we can see that for logarithm of 10 exponent 2 base 10, it can also be written as 2 logarithm of 10 base 10, and that is by the law of logarithm. So we maintain the value for log 6 base 10. Now we know the value of log 6 base 10 already, so we don't get bothered about that, but we work on log 2 log 10 base 10. We know logarithm of a number to the same base gives us 1. So at this point, we're going to have here as 2 multiplied by 1. Now, if that continues, then we are going to have here as logarithm of 6 base 10 plus 2. Now, we know the value of log 6 base 10, and then we do that substitution. So log 6 base 10 from the question is giving us 0.7782. Now, our 8 is something else, so we can clean it and rewrite it well. So we know it's 0.7782, and then we have our plus 2. And when we add these two numbers, our final answer now becomes 2.7782. And this becomes the solution to our question. Now, we can see that this is the end of our video for today, and thanks for watching. Kindly like, comment, subscribe and share. This is BakoMaths, thinking beyond infinity.